shear failures, but mainly we may have this kind of problems. Of course, some chimney type failures due to this very low cohesion of the rock mass may also develop. So in particular, we have three behavior types. Behavior type 1, we have discontinuity controlled overbreaks. This is a case for ground types 1, 2, and 3. Behavior type 2, it's a crown failure or a chimney type failure. Here we have this case in ground type 4. And behavior 3 is a shallow shear failure. We may have this in both ground types 3 and 4. So in the first behavior type 1, where we have this discontinuity controlled overbreaks, the bedding planes dipping medium steep towards the eastern porter are very crucial. And then the next one, the orientation of the main joint sets are independent to the orientation. The primary stress conditions, how they are related to these behavior types, the secondary stresses are below the rock mass strength in the first behavior type. And in the behavior type 2, the small overburden in combination with low stresses and low confinement stresses will dictate the behavior. And in the large case, the stresses at the tunnel perimeter exceed the rock mass strength. So in the maximum, if we meet this ground type in the maximum overburden with this rock mass strength, we will shallow shear failures will be developed. The groundwater, the water conditions vary from dry to minor water inflow from the behavior type 1. The water pressure is low. Again, the same apply to the other two also, because the groundwater here in this tunnel was well below the tunnel axis. So in the first behavior type, we have numerous discontinuity-controlled gravity-induced falling and sliding of blocks from crown and sidewalls. Sliding is preferred along the weakened siltstone layers, so the parameters should be focused also on the weak siltstone layers, not only to the sandstone that prevails in the area. The volume, of course, of the potential overbreak depends on the degree of fracturing and varies of the three ground types. So an underground wedge analysis will be executed in order to calculate in detail these volumes and these safety factors of this case. On the behavior type 2, we have a progressive roof failure, a day lighting failure due to low shear strength of the ground in combination with low confinement stresses. Here in sections with varying ground layers with low cohesion and local water inflow, we may also we also may have some extensive roof failure, so some larger overbreaks. In this, the last behavior type 3, we will have shallow stress-induced shear failures at the side walls in combination with numerous gravity-controlled failures of the ground. So we will also have some gravity-driven failures, but the support measures will be dictated primarily by controlling the strains along the tunnel. By controlling the strains, we will face also some of these gravity-driven failures. Then the radial displacements will be calculated. In the first case, is minimal to 0, and in the two other cases, we may have some small strains. In the last case, in the range of several centimeters to decimeters. In the phase stability, we may have, in the first case, in the behavior type 1, some potential for wedge sliding along the bedding planes in case of excavation from east to west. And in the other two cases, we also may have some larger overbreaks from the face sliding. So we need some face stabilization measures, and of course some small extrusion of the face in the last case of the shallow shear failure. Also, depending on some small fracturing, heavily fracture of the face, some small blocks may also slide and break from the face. So the next case is to correlate these ground types and behavior types with the support category. So 4 support categories were analyzed for these cases and were designed and analyzed, numerically designed, in order to control these 3 behavior types in different stress conditions analyzed before. So starting from the first case, just in order to contain, to keep these wedge failures, you need some thin shotcrete, not very thick, reinforced of course, and Swalex anchors, because you have the siltstone layers, you have this immediate wedge sliding and falls. No steel ribs would be needed here, and a larger excavation around could be implemented. Then, when you go to this rock mass, again, primary problems here in the SCB. If we go back, we will see that SCB is applied again to behavior type 1. So behavior type 1 is controlled by SCA and SCB. So SCA, it's mainly when you find this ground type 1, you applied it, and when you find this ground type 2, then you apply SCB. The SCC, is applied in the behavior type 1 and 3. So spiles are needed here, face buttress, and a thicker shotcrete of 20 centimeters, reinforced in 2 layers, anchors fully grouted. Here the pattern changes, and lattice girders, an excavation round of 1 to 1.5. The point is not to be detailed what is required here, but just to correlate how the steps from the ground type to the behavior type are here respected, and these support measures are dictated by this behavior. The large one, which is shear strain failure and isotropical failure of the rock mass, here you need some pieces of 4 poles and face batteries of shotcrete and face anchors to keep your face safe, and thick shotcrete, a more dense pattern of anchors, and heavy steel sets are required here with elephant foot, and a permanent invert may be required here for this kind of ground conditions. So ending this webinar, in this methodology, engineering geology is in all phases of investigation, design, and construction. So here, our responsibility does not lie just to define a rock mass classification system for the tunnel design. We need first to identify the rock mass types, the ground types, either by using any rock mass classification system or our own rock mass classification system for the case we need, and then to evaluate the rock mass behavior in tunneling, and provide the tunnel excavation support system dictated by these behavior types. And of course, then we can proceed to the definition of tunnel length with equal support requirements and the appraisal of time and cost for incorporation in the tender documents. And where the construction lies here, it lies that for the observational method, that when we have a face and we see something changes, and we see another behavior type of what we have discussed before, so we need to go back and start and proceed, make the same methodology to see what kind of support measures we need to retain this behavior type. If this is described in the design, then we can use this kind of support measures. If it's not, it does not, then we have to go back and make a revised design in order to be implemented in the construction. My references, thank you very much.